Now we are going to see VRRP demo. I'll configure first the IP address on this client machines. The label only we are seeing there, 10001. But inside it is not really configured, it is simply a label. You see this 10001, there is no IP address. This is just a name. There is no IP address, there is no mask, there is no gateway. Let's configure gateway and mask. IP address is going to be 10001. The mask is 8.255.0.0.0. And then the gateway, I'm going to give, listen carefully, this is important. 10.0.0, let's say 100. 100 is the floating IP address that we are going to assign to VRRP later. I'll be assigning this as the address to VRRP to use it as a floating IP address to that virtual router that it is going to create. See, right now if I ping that 100, you will not have any response because there is no interface with 100. Now let us go to that second computer to put the IP address. This is just the name I have given to the computer. It's not an IP address. So let's say 10.0.0.2, mask is 8, and gateway is 10.0.0, what? 100. Now you can see what I have configured. Even from here, you will not be able to ping 10.0.0.100 because the same story, VRRP is still not configured. Only when VRRP is ready, the response will come. I don't have this IP address on any interface. The only reachable IP address now is 10.0.0.20, which is router 2, and the other one is 10.0.0.10. But these two are not our gateway address. Our gateway is what? Now, ARP table, if you see, show ARP. I don't have MAC address for 100 because it doesn't exist. You got MAC address of the physical interface now, which is of no use. We are not going to use that as a gateway. When this is the gateway, answer me, if when this is the gateway, will I be able to ping 20.0.0.20 from this PC? Arun? Why? Why we cannot ping? Because to talk to another network, you need the real reachable gateway. We have an address which is nowhere real now. Let's make it real. I'll go to router 1. Okay, one more thing. Before I do that, on R3, if you see, I have a static route written for the return traffic. I don't have. I have to write a static route. Because ISP router do not know where is 10. Usually we used to do NATing in the real world. But here I'm not going to do NATing. I'm just going to say IP route. In order to reach the 10 network, you send the packet out via F00. Do you agree with me? Do you understand this? Do you accept why I'm doing this? Do you understand this? All right. I don't need a. You understood, huh? Okay. For the return traffic, when I ping from the PC should respond. So the router 3 should know the route to come back. So we are putting the static route. Okay. Even now, if you ping, the ping won't happen because the gateway is still not ready. The gateway is still not ready. You will not be able to reach. I'm going to VRRP now. You see, interface F00, IP, no IP. Simply put VRRP and then put IP, VRRP1 and then put IP. What is this one, you know? That's the group ID. Group ID, VRRP group ID. And IP is the protocol, and the address that I want to give is 10.0.0.100. Actually speaking, to enable VRRP, only this much is enough. See, this router has become master already. The other router is still not configured. Every 1 second, hello packets will go. Because there is no hello packet coming from anywhere else, this has declared this router itself as a master. But now if I go to router 2 will become master. Can you tell me why? If I go to router 2 and make router 2 VRRP configured router 2 will become master and router 1 will go back to backup. Do you know why? Yeah, the IP address on the router 2 interface is 10.0.0.20, which is bigger than 10.0.0.10. I already told you it will not see any other interface, loopback or any other interface. It will only focus on the interface where you put VRRP. Arun, is that clear? Now I'm going to router 2, interface F00, VRRP 1, same group ID you should give. There I gave 1, here also you should give 1. IP, the same address. Now you see this will become master. First it goes to backup and then it understands that I am the master. Preemption is enabled, so it takes the position of master. Now if you go back to router 1 will say I'm moving from master to backup. Let's verify. Show VRRP. You see here, this says I am a backup. This is the floating IP. Look at this. This is the VRRP MAC address. And this 01, the last 01 is the number given by our group. I told you advertisements, hello packets go every 1 second. And the downtime is approximately 3 plus. You don't configure this one. If you want to change this one, you can change to even millisecond. You can change it to even millisecond. You can change the timer. I'll show you after some time. Now, see that preemption is enabled. And see the priority default is 100. And say it says the master router is not me, it is 10.0.0.20. And the master's priority is also 100. Advertisement interval from master is 1 second. I'm also advertising every second. Master is also advertising once. Now let's go to the master. Show VRRP. You see, this says I am the master, and master is local. What is next? Verify pinging. Shall we ping and check? Are you ready? You see? I should be pinging now. You see, it's pinging. Now let's go to, okay, trace route from here. Okay, before that, I would like to show you ARP table. Show ARP. You see the MAC address. Whose MAC address is this? VRRP's. 5E0001. VRRP's MAC address. And now, trace route. Trace 20.00.20. You see, it is going via router 2. Why? Because that's the master. Currently, that is the master. It is going via router 2. Now let's bring the master down. How? I'm going to make this as a master. How? By changing the priority. Do you understand? I'm going to give high priority here so that R1 will become a master. After that, will come and trace. Right now, R1 is a backup. Interface F00, VRRP1, VRRP1, priority 101. This will become a master. You see, it's a master. And now if you go trace the route again from that same PC, this time it should not go to 10.00.20, it should go to where? 10. You see? So we see that failover happens automatically. And I did that by changing the priority. Even if router 2 went down, it would have done the same thing. Now I told you the timer can be tuned. For fast convergence in the real world, timers are very important. People want to know how many milliseconds or how many seconds it will take for the convergence. They want to give that clear information to the customers or to the network users. The data is very important for some manufacturing company. They want to say our router convergence is faster. This protocol convergence is faster. That is how they make business. So the timers are very important. If you want to change the timer, right now show VRRP. It's 1 second. If you want to change, you can change it. Go back to the interface and say VRRP 1 timers. And you see advertise time. If you want to say millisecond, say millisecond. If not, just put the seconds number. I'm saying millisecond, 500 millisecond. Let's go verify now. Listen, I did not configure the hold time. You cannot configure also. The downtime I did not configure. Earlier the downtime was 3 more than 3. When it was 1 second, it was more than 3. Now when it is half a second, it has reduced. What do you understand from this? The downtime interval, the down interval is auto-calculated. Based on the advertisement interval, the downtime interval is dynamically calculated. Now I'll also go to router 2 and show you. Router 2 says the master router's priority is this, but the timer, the local router timer is 1, so the downtime is 3 plus. Let's make this one also as 0.5 seconds. Like, go to interface, VRRP 1 timer 5 millisecond, timer advertise timer in millisecond 500. Now both the side timers are same. This is how it should be. You cannot have one side higher, other side lower. That will cause issue with the hold time. So You can set timer from 50 millisecond onwards, 50 in VRRP. That's the minimum. Are you comfortable with VRRP? Let us now sniff some packet and see. The hello packets, I want to see what MAC address they use, how often they send, all the stuff. So I'm sniffing the wire. You see, it is sending to 224.00.18 as we already know. They use this as the hello packet. And I want to see the MAC address. Look at this, 5E12. If you convert that 18 into hexa, if you convert this 18 into hexa, it will be 12. How can decimal 18 be 12? Let me show you. To write 18 in binary, how do you write? How do you write 18? This place is 4, 2, 1, 8, 16. To write 18, you will put 1 here and then 1 here. All the rest will be 0. Am I right? Now, you need to divide into 4 groups. Okay, because 4 bit of binary equal to 1 bit of hexa. Okay. Now, this is one part and this is another part. What do you have here? 0, 0, 0, 1 means what? 1 only. 0, 0, 1, 0 means what? 2. So 1, 2 is what? You see here. You see 1, 2 here. It is nothing but 18 in decimal. And this multicast, you know, 5E, it will be there in the middle. Who is sending this? VRRP is sending. That's why you have 0, 1 here. 0, 1. And then the group ID. You also see the source is IETF standard VRRP. VRRP ID is 0, 1. So it is like this. It's VRRP protocol. It's an advertisement packet. Virtual ID is 1. Priority is 101. I think it's coming from router 1. Yes, router 1. All right. Okay. The floating IP address is 10.0.0.100. Yeah. VRRP protocol ID is 112. Layer 3 protocol ID. And the TTL that is sent, the hello packets are sent is 255. All right. Fine then.